We've already seen some examples where we're anti-differentiating powers of x. So here's an example. What would I have to differentiate, right? What goes in this cloud so that if I differentiate it, I get 3x squared, right? Or stated differently, what's the antiderivative of 3x squared? I just got to think of some function, and if I differentiate it, I get 3x squared. Well, I can think of one. X cubed, right, is an example of a function that if I differentiate x cubed, I get back 3x squared. Well, what about the general case? So I'm going to think about what would I differentiate to get x to the n. Here I'm going to suppose that x is some number, but it's not -1, right? So in other words, I want to know what the antiderivative of x to the n is, right? So I'm thinking, what would I differentiate to get x to the n? And I'm going to claim that it's x to the n plus 1 divided by n plus 1. Now, how do I know that this is the antiderivative of x to the n? Well, all I've got to do is differentiate. Right? I'll differentiate x to the n plus 1 over n plus 1. And I'll do that with the power rule and the constant multiple rule. This constant multiple just comes on out of this differentiation. So I've got 1 over n plus 1 times the derivative of x to the n plus 1. Now, what does the power rule tell me? The power rule tells me how to differentiate this, right? That's n plus 1 times x to the n plus 1 minus 1, which is just x to the n. But now this n plus 1 and this n plus 1 cancel, so what I'm left with is just x to the n. And that's exactly what I'm claiming, right? That the antiderivative of x to the n is x to the n plus 1 over n plus 1. I should be careful to point out something here. Well, here's a potentially subtle issue. Let's suppose I want to antidifferentiate 1 over x to the 5th. Right? Well, I could write this as antidifferentiating x to the n, right? Well, just for some value of n, right? n here is -5. Now, the power rule tells me how to antidifferentiate x to the n. It's x to the n plus 1 over n plus 1 plus c. Okay, now n is -5 in this case, so that turns out to be x to the -4, right? -5 plus 1 over -5 plus 1, which is over -4 plus c. Now, if I liked, I could simplify this a little bit, or at least make it look a little bit nicer. I could write it as -1 over 4x to the 4th, right? I can put x to the -4 in the denominator, plus c. Great, so an antiderivative for 1 over x to the 5th is -1 over 4x to the 4th. And here, I'm claiming that I wrote down the most general antiderivative of this thing. The issue that you have to worry about here is that this plus c is really hiding something. This plus c really means something that's locally constant, not necessarily the same constant on the right and the left-hand side of 0. Because this function's not defined at 0, so you could play with the constant. You can make it different on either side of 0. That's, a subtle point, but it's worth pointing out, I think. What if I wanted to anti-differentiate a polynomial? For example, let's suppose I want to find a function big F so that the derivative of big F is little f, and maybe little f is a polynomial, like maybe little f is 15x squared, I don't know, minus 4x plus 3. Right? So I'm really asking for an antiderivative of little f. I'm asking for a function whose derivative is this polynomial. We can totally do this. So let's do this using the notation that we've been developing. So I'm going to write antiderivative of 15x squared minus 4x plus 3 dx. And this is the antiderivative of a sum and a difference, and that's the sum and the difference of the antiderivative. So I can write this as the antiderivative of 15x squared dx minus the antiderivative of 4x dx plus the antiderivative of 3 dx. Now, I've got the antiderivative of a number times something, so I can pull these numbers outside of the antiderivative. So I'll rewrite this as 15 times the antiderivative of x squared dx minus 4 times the antiderivative of x dx plus, the antiderivative of 3 dx. Okay, now I got to think, what's the antiderivative of x squared? Right? What's just an antiderivative of x squared? Well, I know one. It's x to the 3rd over 3, right? That's the power rule running in reverse. Minus 4 times, there's an antiderivative of x, something that I differentiate to get x. Well, that's x squared over 2, right? If I differentiate x squared over 2, I get back x. And what's an antiderivative of 3? What's something I differentiate to get 3? Well, 3x is such a thing. And to write down the most general antiderivative, I'm going to add plus c here. So this is the antiderivative of this polynomial, and I could write this a little bit more nicely now since some of these things cancel. 15 thirds is 5x to the third minus 2x squared plus 3x plus c. Here we're using a sum rule, a power rule, and also a constant multiple rule that we haven't seen yet. So it's worth writing down that constant multiple rule explicitly. So remember what the constant multiple rule says for just differentiation. Yeah, if I differentiate, say, some number a times some function big F of x, well, that's just a times the derivative of big F of x. Now I can write down the same kind of rule, but for antiderivatives. For antiderivatives, if I'm antidifferentiating, say, a times little f of x, well, this is the same as a times the antiderivative of f of x. It's not too difficult to justify this. So yeah, let's try to justify this constant multiple rule for antiderivatives. Let's suppose that f differentiates to give me f of x. So I'm really supposing that big F is an antiderivative for little f. Then this side here, I could rewrite a times the antiderivative of f as a times big F, which is an antiderivative of f, all right, plus c. So now if I'm claiming that this, the antiderivative of a times f of x, is this, it's enough to just check that the derivative of this is really this. And that's true, right? What's the derivative of a times f of x? Well, that's exactly what I did up here. You know, these rules for antidifferentiation are exactly coming from the rules for differentiation. So the derivative of this constant multiple times f of x is that constant multiple times the derivative of f of x, right? And I'm claiming that the derivative of f of x is little f. So this is a times little f of x, which is exactly saying that the antiderivative here is this. This is what I'm trying to justify.